My name is Chris Yu, and I am an aerodynamicist at Specialized Bicycle Components. Specialized Bicycle Components is a world-class manufacturer of not just bikes, both road and mountain, but also all the equipment as well, such as wheels, tires, clothing, helmets. We happen to be at the Tour de France because we make some pretty fast road bikes, and we have just launched a new one this year. This bike is our go fast bike. It's our race bike. So it was designed for aerodynamics first and foremost, but very, very close partner to that in terms of target was that structural and weight. So keeping those things balanced in terms of the design process was one of the things that we did throughout. When it comes to designing a new product and trying to optimize for aerodynamics, really the foundation and the first step is to go through simulation to see what we can get, because it's really cost and time prohibitive to go and make 1,000 prototypes, whereas in simulation you can really explore the boundaries of that envelope to figure out which design direction to go. So when we have a road race like the Tour de France, there are many stages where aero is the biggest factor that the riders have to overcome, but there's also a lot of stages that are basically pure hill climbs in the sense that you're fighting gravity. And in those cases, minimizing weight up to the minimum that's allowed in the rules is a big deal. So having the tools to be able to optimize the system to have minimum weight for the aero and structural targets that we've set is super critical. For me, the CFD capability in HyperWorks is extremely efficient and robust, and those are kind of two of the really important things, because when someone comes out with the CFD software in industry, to some extent that it's going to be accurate enough if you set it up correctly, but really the key points are the efficiency and the robustness. And what I mean by that is just being able to run the problem quickly, and also being able to set up a problem with, not perfect CAD. AccuSolve's ability to take, not great CAD models and still be able to run the solution is a great feature. With this bike, not only do we use AccuSolve for the fluids optimization, but we also use OptiStruct to optimize the structural and the carbon ply-by-ply analysis. So by using that, we're able to ensure that we don't have any excess material anywhere in the frame. Virtual wind tunnel has been honestly fantastic for the work that we're doing, because a bike is an external vehicle, so setting up that problem, there's a lot of similarities from model to model, whereas virtual wind tunnel is basically smart enough to know that with a vehicle there's a certain few things that you want in terms of boundary conditions on the ground and inlets and outlets and things like that. So just being able to streamline that process makes it so much faster in terms of turnaround for different models. And just to put it in perspective, for something that matters for an elite level cyclist, we're talking about a few grams force equivalent of drag. So it's a very, very small quantity, so it's hard to measure. And so when we started transitioning into using powerful tools like Altair HyperWorks Suite, we're able to realize that a lot of those small changes that maybe you can't physically measure individually, if you stack them up in simulation and then build a prototype, you're able to then measure a very, very large gain in the tunnel. By using the HyperWorks tools and the CFD analysis, on this frame especially, in terms of the amount of prototypes that we're able to put through the simulation in the time block that we had to design this thing, I feel like is at least a 2- to 4-fold increase over what we had before in terms of the number of prototypes that we're able to run virtually.